Hi, I'm Steve Halladay, and in this video I'm going to show you how to control the DC motors using your MotorShield with the software. As you may know, your remote control car uses DC motors for both the steering and the drive mechanism on the car. So in this video we're going to show you how to control these DC motors. We can make them go fast or slow, backwards or forwards. And this is a little bit more sophisticated than what's required for the servo control because we need to use some AdaFruit libraries to help us along with this, but it's not too bad anyway. So I'll show you how we're going to do this. Let's get started. The first thing we will want to do is to download the library software that AdaFruit supplies for their MotorShield so that we can use this in building our software. So what we'll do is we'll go to the AdaFruit page on the MotorShield, which is where I am here at this URL. Next we'll click on the install software link here, and that takes us to a page where we can download the MotorShield library by clicking this link right here. The result of the download is a zip file in our download folder, and we'll go into the Arduino app and we'll install that as a library. Now in the Arduino app, what we can do is we can add the library. We can go to the Sketch tab here and we can import library, add library. And this brings up a file selector window, and so in my downloads directory I can look through here and I can find the AdaFruit zip file that I downloaded, and I can choose that. Next what I will do is I will add the library to my sketch. You can see that it appears down here, down in this bottom of my window for libraries here now. And when I do that, you can see that it creates this include file. Notice that I have the simplest sketch that I can have at this point with just the setup and the loop like we've talked before. And then I add this library. Now in addition to this library, I've found that I also need to add one more thing here, and that's I need to include wire.h, and that's with a capital W again. Evidently the AdaFruit MotorShield uses wire.h as well. So now we're good to go. Now we can actually start programming this. So to program the motors, the first thing I need to do is add a line here that creates a MotorShield instance here. This is a factory that allows me to get access to motors. And then the next thing that I'll need to do here is I'll want to create an actual instance of a motor. I'm going to call this drive because this is the one that will drive the wheels. Notice that I've connected this to the motor 2. Remember we had 4 possible DC motors we could hook up to our MotorShield, and I've chosen to hook this one up to the motor 2 section. You'll see that that's labeled on the MotorShield itself. Now once that I've completed that, I can actually call the begin method on the MotorShield library. That sets up the MotorShield so that it's ready to go. The next thing that I'll want to do is set the speed on my motor so that when it does run, it will run at the speed that I want it to. I do that with this call to this method right here. Notice that drive is a pointer. That's what this asterisk in front of the variable drive means. And so when I want to call a method on drive, I have to use the dash angle bracket, the arrow, because it's a pointer, as opposed to the period that I would use up here on the AFMS, the MotorShield instance, because this is not a pointer, this is an actual object, so to speak. The parameter to the set speed can be a value between 0 and 255. It's a byte value. So any value between 0 and 255 is a reasonable value. I've set it to 150, which is sort of in the middle. I guess 128 or 127 would actually be in the middle, but we're pretty close to the middle. And then the last thing that I need to do is I need to run the drive at release. This means really turn off the motor. So run with the parameter of release means turn off the motor. These values of release, you can actually put in here release forward or backward, and these values are defined in the MotorShield.h file up here. So now I've initialized the motor, and then the next thing I should do is get it to run. I'm going to get it to run forward, I'll delay for a while, and then I'll have it run backwards and I'll delay for a while again, sort of like we did with the servo. And here's what the code looks like to get it to run forward for a little bit. We'll turn it on to run forward, we'll delay for a second with it running forwards, and then we'll make it run backwards and we'll delay for another second. It'd probably be wise for me to stop it in between for a little bit, but I won't do that. I'll just make it run forwards and backwards. So when I push the button to upload the code, it compiles and uploads the code, and here's what the car looks like when it runs. Next, let's modify the program so that we also move the steering on the car. So the way we'll do that is we'll create another motor here, be just like this one, only this time we'll hook it to motor 1 and we'll call this one steering. Similarly, with the steering mechanism, we will set the speed and we'll release the motor to turn it off to start with. I'm going to set the speed to 255. Interestingly enough, if you take the steering mechanism apart, which of course I did because I'm an inquiring mind, you see that it's built out of a DC motor that basically just causes the motor to shift all the way to one side or the other. It doesn't actually spin, it just forces the steering mechanism one way or the other. And so setting it 255 just says I'm going to, when I turn the steering one direction, it's going to go as hard as it can that direction, and then when I turn it the other direction, it's going to go as hard as it can in that direction as well. Finally, I'll add a couple of lines here to actually cause the steering to move. I'll go forward first, which will either go right or left, I can't recall for sure, and then I'll go backward second, which will cause it to go the opposite direction. Oh, let's see, let me put this line up here before the delay. So now what we'll see is we'll see the car move forward and the steering will turn one direction, and then we'll do that for a second, then the car will move backward and the steering will turn the other direction, and it'll do that for a second, and then that'll sit in a loop. So when we run this program, here's what the car looks like. Finally, one last change I'd like to make to my program to make it a little bit easier to use. You recall that I wasn't sure whether forward was left or right on the steering, so once I figured that out, I'd like to kind of keep that straight in my mind. So what I'm going to do, and I've done down here, is I've created 3 different additional methods. I called them steer left, steer right, and steer straight, and I can use those as sort of pseudonyms for what I'm doing here. So instead of steering forward, I can say steer left, and then down here, instead of steering backwards, I can say steer right. And that way I can keep it straight, which way is going left, right, and straight, instead of trying to remember backwards means left and forwards means right and so forth. And additionally, I might do the same thing, and I have down here with the drive motors as well. So I've got to go forward, go backward, and actually this stop method isn't going to work very well. I'll capitalize the S just because stop seems to be a method that's already defined. Because of the red highlight, I could see that. Maybe instead of a capitalized S, maybe I'll say go stop, which doesn't make a lot of sense, but it's consistent with these others as well. So then I can change these calls up here, and right here I can say go forward, and then down here I can say go backward. And we see now that reads quite easily. Go forward and steer left and delay for a second, then go backward, steer right, and delay for a second. And so this will basically behave the same as the previous example that we saw. So there you have it. You have all the information you need to be able to get your car to go forward and to steer it. And then in the previous video we also saw how to control the servos as well. So now we know how to control all the motors for our autonomous vehicle. In the next video we'll look at accessing the sensor data. Also remember, if you want to follow along with us, feel free to pick up a kit at swarmus.com where you get all the parts that you see in this video. I look forward to working with you on the next video where we start to access the sensor data.